For page 3, we start out with a problem here where we get the values of 4 integrals from a graph. And you're told that the graph consists of these line segments. Everybody's graph was a little bit different, at least the 3 sections, 3 different versions of it. So I won't go into a lot of detail here, but I'll do the first one, I guess. So the integral from 0 to 2, we know the integral is the area. So if we go from 0 to 2, we're looking at, let me switch to red. The area of this trapezoid. So, 1, 2, to me, like there are 4 units of area there. There are these 2, and then this triangle is half of this square that has 4 units. Okay, and then we go from 2 to 5, no tricks. 2 to 5, this trapezoid, and the only other trick here, the only other things you need to be aware of, notice there's a 4 tucked in here. Some of you missed that. It should create no confusion, just bump it out of the way. And then we go from 5 to 9, f of x dx. And notice that from 5 to 9, the graph is below the x-axis. So we're going to get a negative number. I'll let you figure out which one. And then finally, the integral from 3 to 0, this from 0 to 3, the function is always positive. But because the limits are backwards, this is also going to be a negative number. And you can just, I guess the answer would be -7, because to the 4 we got on part A, we're going to add 3 more squares right there. So the value down here is -7. All right, finally, using the same graph, let's see if I can leave it on the screen there. I can make it a little smaller maybe. All right, determine the values of a of 0. Well, notice the integral, the definition of a is defined as an area function. It starts at 0, so it shouldn't take us but a few seconds to realize that a of 0 is 0. And then we want to know what a of 1 is. Well, it's the area from 0 to 1, and that's 3 halves. You can see on the graph. We're only going up to 1 now, so the area of that little guy right there, we got a square and half a square. And then finally, a of 3, I think we calculated it in the problem above. Well, we calculated the opposite of it right here on part D. We went from 3 to 0, we got -7, and therefore the answer here is 7. Okay, and you could recount it again, didn't have to use it. Part B, what is a prime of x? It's f of x. When you define an area function like we did here, then its derivative is the function that generates the area. A lot of you wrote f of t, and I guess I understand why you did. It's really not right to say that a prime of x equals f of t. That just looks confusing to me. I knew what you meant, at least I assumed. But it's really not right. We ought to write it correctly, and that is a prime of x is f of x. At least one person wrote the definition of the derivative, which that's what a prime is, but it's not the question I asked you. I said according to the fundamental theorem of calculus. Finally, what's a prime of 7? Well, if you got part B right, then a prime of 7 is just f of 7. And so we'll go up to our graph here. I've kind of obscured it, but it looks to me like 7 is here, and we're down at -3. And part D, does a, the function a, have any local extreme values? Well, we look for critical points. That is, we look for places where its derivative is 0. Since its derivative is f, we're looking at any place that f is 0, and there is one. Let's go to green, right there. So x equals 5 is a critical point. the only critical point. So, is there a min or a max there? Well, again, this graph, the original graph here, which I've sort of cluttered up, I can clean that up, maybe. No, I guess I should be able to. Well, I'll just leave it. Critical point right here at x equals 5. And notice the derivative, again, this graph is the derivative of a. And notice that it's positive to the left, which means a is increasing. Its derivative is positive. And as soon as it passes through this critical point, it becomes negative, which means it's decreasing. So by the first derivative test, we have a local max. So I did say to answer specifically, the max is specific. And justify, I justified it by by using the first derivative test, by referring to the first derivative test. I could give just a little more information. I could say exactly what the maximum value is. I'm not sure if I asked you to do that earlier. It would be a of 5, whatever that is. Yeah, I didn't ask you. I sort of did. Between a and b, you could add those answers up and you would get a of 5. Okay? But we'll say specifically is to say at 5, there is a max, and justify your answer by referencing the first derivative test. That's it. Happy studying.